How you doing? Awesome. Let's go ahead and get started with the items for today. I'm going to go into my notebook here. We've got a lot of notes. Look at all this stuff, man.
We're almost done with it.
We are. We've definitely hit the official halfway point.
Nice.
I know, right?
I think on my journal.
I adjusted the size of the title and the objectives. Does that make it a little easier to see?
Yes.
Is that helping you guys out a little bit? All right. All right, so we're starting our study of trigonometry. And let's discuss what this word means a little bit before we get into it.
That sounds hard.
It does sound hard, but it's actually really easy. And I'm going to try not to kill the topic and make it super boring. Let's look at this word real quick. This word part here, tri or tree, stands for, guys, this word part tri here at the very start of the word stands for 3. And then this word part right after it, G-O-N, gon, stands for sides. So we have 3 sides. This O kind of connects the word, I guess. It's like an of or something. So 3-sided, and then metry is Greek, where we get the word measure from. So this is 3-sided measure, and there's announcements.
Right on time.
Good morning.
All right, so now that announcements are done, thank you, announcements.
And I show you how to question.
Yeah,
It's irrelevant though.
it's irrelevant. Then let's ask after. So write it down so you don't forget, and then ask me right after lecture.
Of course I forget.
Write it down. All right, so we've discovered what trigonometry means. It's the measurement of 3-sided figures. So let's figure out what these trigonometric ratios are all about. I know, what a word, right? Trigonometric ratios. Trigonometric ratios is a ratio or a fraction of the lengths of 2 sides of a right triangle.
are we gonna do this next year too?
Yes, I'm trying to give you some really good, strong foundation for you for next year.
But it's pretty easy, man.
Good.
You've done this
Yeah.
Good.
It's up to all.
before? I don't know if we're doing it or not.
All right, so here we go. We're going to draw ourselves a right triangle. I need 3 letters. Go.
J.
C.
Hey, A.
A.
Those are the ones that I heard nice and clear. All right, so A, trigonometric ratio. Of triangle JK or JCK is JC over CK. You're grabbing 2 sides and you're making a fraction out of them. And that's all that's really happening here.
That's it?
That's it.
Wait, what?
That's it. We just grabbed 2 of the sides and we wrote them as a fraction. And we said, yay, it's a trigonometric ratio.
That's it.
That's it. That's all this is.
Dang.
But we have specific trigonometric ratios that allow us to do specific things. And as we continue working with them, we'll start discovering what it is that these things allow us to do.
Wait.
Miss, haven't we been doing
B.
this whole time?
Yes.
But now we have a name for it.
But now we have a name for it.
Oh.
The first special trigonometric ratios is called the sine ratio, and it's written this way. And it is abbreviated as sine theta. The word isn't pronounced sin, it's pronounced sine because it's just the short version of this. Okay?
You drop us over hypotenuse.
And here is the word version of this. The sine ratio is the ratio of the length of the leg opposite theta, which is our reference angle, to the length
Bless you, Mark.
of the hypotenuse. Let's draw some diagrams. Because this is very wordy. It's just a lot of words. Alright, so we're going to draw 2 right triangles just so that you can see them from different angles. So there we are, 2 right triangles back to back. I need names, go.
B.
R.
A.
C.
Oh,
A.
that.
Alright, thank you very much.
Is that a Z?
It is a Z.
Okay.
And this is a J.
R.
Alright, so we're going to try to find the sine of this angle theta that's sitting here at B. So the sine of theta in this case is, according to my definition, the leg opposite theta over the hypotenuse of my triangle. Alright, so where's the side opposite my angle theta? Well, if we look at theta,
It's from the adjacent angle.
you're going to shoot like an arrow. I don't know, can you see the yellow? Very faintly? Good.
Barely.
And this side right here is the side opposite theta. What's the name of that side?
JR.
JR is the name of that side. It is the one that is opposite to.
C8.
Oh, so the little bolita has to be opposite to the other side?
Has to be opposite the side for this one, yes.
C8.
And the hypotenuse is which one?
C8.
The opposite of R.
Yeah, it's opposite of R. B to J. And there's your hypotenuse. All right, let's find the sine of this triangle over here. Sine of theta.
Miss, can we use B and R also and then use
Not for the sine, because of how it's set up and where theta is.
So, Miss, it was like numbers there. You gotta put the numbers instead of the letters.
Right. That's going to be the final example of the day. So let side conversation. Thank you. What's the side opposite theta in this triangle?
AK.
AK is that side opposite theta.
Oh, I see. How we got that.
And what's the hypotenuse of this triangle, ZAK?
ZK.
ZK, very nice. Because it is the side opposite the 90-degree angle.
Miss, when
Yep.
we get a worksheet, are they actually going to put the subject there?
Yes, we'll actually put theta. You'll see in the last example that you can also do it with just the letter and not having the
So you're gonna put the little
thing.
circle on the.
I'll
on the-
either put theta, that's the name of it. It's not a little circle. His name is theta. I'll either give you theta or I'll somehow name the angle for you.
Miss,
And you're gonna put
why
the.
can't you just put the
90
adjacent
degree?
angle?
We haven't done that yet.
You're gonna put the 90-degree angle too.
Yes, and the 90 will be marked for you. Now, this shortcut here, sine theta, is shortcutted as O for the opposite divided by H for the hypotenuse. And that's what we did for all of these. Let's look at cosine. Our next trigonometric ratio is the cosine, spelled just like sine, but we're going to put the word co in front of it. And it is the ratio of the length of the leg adjacent to theta to the length of the hypotenuse. Hypotenuse remains the same hypotenuse as from the previous example. So let's draw two triangles.
Miss, what was that adjacent again?
What did the word adjacent mean?
Can we do like a recall thing?
Yep, recall. What did the word adjacent mean?
Isn't it,
Isn't it to
Isn't
the other
it-
side of the
yeah.
angle?
What do you mean to the other side of the angle?
The opposite side.
No, that's opposite. That's not touching.
Isn't it adjacent where it's right there, like the L where the 90 is?
Yeah, it'd be this one right next to it.
Connected?
Yeah, next to and connected.
I never got that.
Someone found it way back then. Adjacent, next to, and connected. All right, name the triangles. Go.
B R
A.
Z
A.
C.
I heard L,
M.
K, and M. I have an L right here. All right,
Alright.
let's make one of the. There we go. There's thetas. And we're going to abbreviate cosine as COS. It's not said cos, it is said cosine. Even though it's only 3 letters and it totally looks like it should say cos, it's an abbreviation. So that is cosine. All right. It says that cosine is the side adjacent to, next to, and connected. So in this angle, angle BRA, which is the side adjacent to
BA.
theta. He said BA, this one right here, it is BA because it is not the hypotenuse, but it is still next to theta.
Yes, trigonometry is so easy.
It really is.
It's a big word.
It is a big word. All right, give me the cosine ratio for this one.
Okay.
LK is the side adjacent. And the hypotenuse?
LM.
LM.
And this one, it's the cosine over the hypotenuse.
The adjacent over the hypotenuse.
Oh, yeah.
We're going to abbreviate that ratio as cosine theta equals A for adjacent over H for hypotenuse.
Miss, how are the adjacent angles connected?
The adjacent sides. This is the side adjacent to the angle. So if you look at this angle here, this side is adjacent to it. It's touching. It kind of helps make up the angle, but it's not the hypotenuse.
Where'd you get A from?
It's because I'm trying to,
Oh, never mind.
with the both triangles, see how they would be connected according to the way you highlighted.
We're not talking adjacent angles anymore, so these angles aren't next to each other. It's the side next to the angle that we're worried about. All right, our final trigonometric ratio for the day is the tangent ratio. This is the ratio of the opposite to the adjacent. And I'm abbreviating, shortcutting here because this is the same opposite and same adjacent that we've already done earlier in the page. So I'm going to go ahead and color code them the same way. Let's draw our triangle, our diagram. Name it.
A.
B.
A.
Hey, let's go.
A, R, and B seem to be very popular letters this morning. All right, we're looking at the tangent of theta. When you see this, please read this as tangent theta. Don't read it as tan theta. We're not putting this guy out in the sun on the beach to get a tan. This is tangent theta. All right, so let's put theta down here for now. What's the side opposite theta?
AB.
Very nice. What is the side adjacent to theta?
RB.
Very nice. Write your ratio.
So is the one like touching it or?
Mm-hmm.
Miss, what if we write it backwards? Is that gonna mess up the whole thing?
Okay. Let's be specific about what you mean by write it backwards.
As in,
BA.
like on the cosine.
Okay.
theta, what if we put H over A?
Then it's not cosine. It's something else. And I can give it to you briefly, but it's not something you really work with until you hit algebra 2 a little bit, and then pre-cal and calculus you really play with it.
What if you put like BA?
If you put here AB or BA as the adjacent, that doesn't matter because you're still naming the same side. Okay? So the tangent of theta we will abbreviate as O for the opposite over A for the adjacent. Right, I'll give you guys about 5 more seconds and I'm going to change the page and we're going to do this example with numbers.
So control, man. So you know you're already done?
Not yet.
I mean, that's how I remember it.
That's fine, which is a great, but I want to just introduce it and then we'll.
It reminds me of that battle Sakajui.
Yep.
What did you eat? That was never
Second
done.
Maya.
Cinco de Mayo?
What's the battle with the S?
I don't know.
Second Maya.
I don't.
Yes, it's on.
Miss, am I gonna have
It's okay, Ryan. It's
Hey, I
okay.
know
We know you're
some-
not.
No, probably not. We're gonna need a good.
I know some history.
If you write really,
That's good. You know
if
something.
you write really small, you might be able to get it. Yeah.
That's true.
And I think y'all don't even know what battle Waterloo was.
I'm so confused. Let's do this example. All right, here is the example for the day. It says express the trigonometric functions, or ratios, excuse me. Express the trigonometric ratios as fractions. Tomorrow we're going to start playing with them in decimal form, and all you have to do literally is just type the fraction into the calculator and hit Control Enter so that it gives you the decimal form, and that's it. And round it, and you're done. Okay. So draw yourself a nice, beautiful right triangle. Name it.
B.
Hey.
There we go. Those
We
are the
should've
three that I
named it-
heard. Nice and loud. Thank you
We
very
should have
much.
done it CAM, Cam.
Cam. And here are the measures of the side now, as I mess up that one.
Did you notice that?
All right.
Lost to the regular.
All right, so let's look at writing first the sine of our angle theta. Which angle do you want to be theta today? K or B?
B.
B, you want B to be theta? All right, so angle theta. All right, what's the sine of angle theta?
And Q. Wait, what?
What sine?
CB.
It's opposite over hypotenuse.
KC.
So KC over
KB.
KB. Fill in the numbers. What's the side measure for KC?
15.
15 is the measurement of the side opposite theta.
8.
And
No.
what is the measurement of
17.
KB? 17, that is the measure of our hypotenuse. There is the fraction of the trig ratio sine of theta.
We were just like, what kind of question would that correspond to?
An express, write it, the ratio kind of question.
That exactly.
Yeah.
What about
It's
like
point
what
eight.
if
First
like
word
that?
two.
Yeah, you put this and then you're done.
No, I was gonna ask it as a question, like,
You may be asked for it as a decimal, in which case you put this ratio in your calculator, control enter, and you get a decimal. Yeah, or you do this division thing. Whoops.
You can see this.
I don't know.
Oh, no.
It's really bright. Let me see if I can't turn down the brightness. How do you, here it is. There we go.
That's too dark.
There it is. So you can do that and get the decimal form. All right, let's write the cosine of theta. Which is the side adjacent to theta?
CB.
CB. What's the hypotenuse?
KB.
KB. Fill in the numbers.
Oh, 8 and 17.
Perfect. The final trig ratio for this one is the tangent of
Do we have to
theta.
do all of them?
If you're asked for, we're going to do all of them so you can see how to do them. Tangent is
Isn't it
opposite
over adjacent?
over adjacent.
AC and CB.
Beautiful. Fill in the numbers.
15 and 8.
15, 8.
Lovely. Now, theta isn't the only way to reference or name an angle. You may also see it named by the letter. So what would be the sine of angle K?
Sync.
Does look like it's sync. What is the sine ratio again?
It's
Opposite
so wouldn't it be
over hypotenuse. So opposite over hypotenuse. Substitute your numbers.
8 over 17.
There it is. What is the cosine of angle K?
Cos.
Yeah, it looks like it says cos, but it's cosine of K. That's supposed to be a C.
Isn't it CB, no?
CB, we're looking for angle K. So
Eight.
here's your reference.
8 over.
What's the side adjacent to this angle right here?
AC.
KC. What is the hypotenuse of the triangle?
CB, no, KB.
KB. Substitute your numbers.
15 and-
No, yeah, 17.
There you go. And last but not least, what is the tangent of angle K?
K, no. KB.
Opposite
Oh,
KC. CK.
Opposite from this one.
CB.
CB is opposite angle K. Adjacent to angle K is
KC.
KC. Remember, on the adjacent, do not pick the hypotenuse.
Hypotenuse.
And there it is.
Wait, so
Bravo.
when it asks for
Trigonometric.
Trigonometry.
the ratios, we put all three of them.
You put whichever ratios you're asked to put. So if I say express the given trigonometric ratios and I put sine of whatever,
Trigonometric.
you just give me the sign.
Okay. And what do you mean by K? Why did you put by K?
Instead of giving you angle theta, I named this angle with K. I used the angle name. And you could use whichever one of the versions that you want. You'll see me interchange them, so I want you to be familiar with it.